Hello, in this video of our machine learning using R series, I want to talk about how to implement bagging from scratch. As you know, there are three basic methods ensemble techniques: bagging, boosting, and stacking. So in this video, I want to show you how to actually implement the bagging from scratch, which means we're not going to use R packages that already have built-in bagging mechanism. First, just a quick overview of bagging. Okay, so bagging reduces variance by training multiple base learners on bootstrap samples and aggregating their predictions. It uses bootstrap sampling, training on each sample, and combining via majority vote for classification or average for regression. Base learners are trained independently, enabling parallel processing. It aims to reduce variance while generally leaving bias unchanged. Decision trees are a classic base learners. Others can work also. And each bootstrap sample has the same size as the original dataset and is drawn with replacement. So out-of-bag estimates use the unseen data, about 37% to estimate error without a separate validation set. And it is robust to noise and can handle class imbalance with adjustment. Random forests are a key variant, adding feature subsampling to increase diversity. So random forests are really the best example of bagging, but of course it also implement other techniques. The limitations of bagging include higher computational costs and potentially limited gains for already stable models, or the signal is strong and simple. All right, let's get started. Random seed, sample size 200, and create a data set with a dependent variable y, which is binary, and then three predictors x1, x2, x3. First, we can write a basic function of, now we're using decision tree, okay, using recursive partitioning. So it's a stump-like for simplicity. This uses a greedy decision tree splitter. It searches for the best feature and threshold to split the data by maximizing information gain, here measured with Gini impurity. Okay, so you can see the syntax here, reading data and tell the function will target the column as y. So in that data set, the dependent variable must be labeled as y. Okay, you specify the formula and then you create these placeholders for best split, best variable, best threshold, and then you do this initialization and also create the Gini impurity, which is a function written in CLS, returns in this 1 minus sum table CLS divided by length CLS squared. And then you can calculate the parent Gini, the left or right Gini, then calculate the gain. And if the gain is larger than best gain, then you update the best gain, best variable, and best threshold. And then you go down there. If no good split, then you just make a leave. And if you have a best variable, you have a good split, then you do this operation, update the left data, right data, then the left prediction, the right prediction, and then you draw this function, and then you generate the predictions and then return. Okay, so that's the basic function for the split, and then we can using the bagging, performing bagging, to use that basic split function to the tree function to actually as the base learner, okay, to fit trees, then aggregate by majority vote. So writing the data, the test data, and then we say b equal to 50, target column is y, and then you create a list of trees, and then you do the bootstrap, and you call that in that loop for I from 1 to B, you repeatedly create the tree, the trees like the ice tree by repeatedly using the tree underscore fit function. And then you aggregate predictions. So the tree predictions like that. And also the classes. So basically, this is for returning the predicted classes. Okay. And then you can split the data into the training data set and the test data set, and then you can do the bagging like making prediction after the bagging. Okay. And then you can calculate the accuracy, which is the mean of bagged predictions equal to the test data predictions. Okay. And here it is 0.833. So you can see the basic implementation of bagging is you create like a basic learner like this in this tree underscore fit function, and then in that you use this to do the bagging, which create a bootstrap and the fit based learner, and for the time you specify, and then use it on the test data set and a training data set, and then predict the test data set, you get the accuracy. Okay. So hopefully you can get some idea of the mechanism or the steps of implementing bagging from this example. I will share these R codes in the comments area of this video. And if you like this video, please subscribe to our learning channel and also recommend this video to other learners. Thank you very much.